Wonderful. Well, welcome everyone. My name is Eli Storch, the chair of the Design Advocacy Group, and this is DAG's February 2022 meeting on why buildings leak. We are thrilled for today's presentation, and I want to get through our regular order of business so we can dive right into it. So if you have any announcements, any events, any ongoing exhibitions, galleries, things you want to share, please put them in the chat. We'll call on you to talk a little bit about what you're working on or what the event is, so we can pass it along to the community here. So if you have anything, if you can think of anything, please share that in the chat. Any technical difficulties throughout the presentation, you can message David Brownlee, you can message me. We will do our best to assist you. But beyond that, please stay muted, and we do hope you enjoy. So typically our meetings, we've been off the record, but with the ability to record via Zoom and share them more broadly, we have elected to do that. So you can go on our website and see back to September of 2020 was when we initially started. All of our DAG programming is on our website through the events page, and you can go back and check out a bunch of really wonderful monthly meetings. So please do that, and those have been really great to share more broadly than in the past. It's also a pleasure now that we're in the new year and all the tallying has been done to say that DAG has met our 2021 fundraising goal, largely because of folks like you on the call today. We are entirely supporter funded to keep ourselves going and to fund our DAG fellow who does wonderful work for us, as well as support our advocacy agenda and continue to move things forward at DAG. So thank you to all those who contributed. We have a lot in the works. One of those things in the works that we can talk about is our Streeteries working group at DAG. We have been pushing and pulling and evaluating content and trying to come up with some design guidelines and recommendations that we feel are important as we're looking at the future of streeteries in Philadelphia, as the city prepares to launch its newest legislation in March on what will become of permanent-ish streeteries. Design is not truly going to be considered in this bill. It's about operations, it's about safety, it's about a lot of important things, but we are going to be looking at these. These are going to make up a significant portion of our street life and culture for the foreseeable future. So we're working on that, and we're trying to develop some guidelines. And with that in mind, we're going to be hosting a program on March 3rd. I put the events link in the chat. So if you go to our website and sign up for that, that will be a mix of a roundtable discussion. We're going to try to be very free form with it, get a lot of feedback. There's also a really great panel. We have Beige Berryman from the Planning Commission and the Arts Commission, Ben Fleccia from Pennsylvania Restaurant and Lodging Association, Thomas Steinborn from FREDA. We have Mario Gentile from Shift Space Design, who's designed some really lovely parklets, who he's going to be a part of it. And of course, the fifth person I always leave out, and Prima Gupta from Center City District, who is going to give us some really interesting insight as a commercial corridor manager and take part in that conversation. So that is March 3rd at 6 o'clock, and you can get a free ticket to that through our website. So please check that out. I'm going to pass it over to David Brownlee for a few advocacy announcements. Please, if you have anything for the chat, put it in there and we will call on you to shout those out and tell us about them.
Hi, welcome to everyone. I want to reiterate the invitation that Eli issued to send us a small amount of money. We need a small amount of money, and you have a small amount of money, send it to us on our website. I also want to invite you, if you have something that you want to get off your chest in something more than a 3-second sound bite here, please submit an essay to DAG Forum. You'll find instructions on how to submit such a piece on the website. We just posted a new piece by Sean O'Rourke taking how shall we say, a different view of Frank Gehry's work inside the PMA. And I invite you to take a look at that. I want to give you an update on a couple of things that we're watching, that we're tracking. One is that I put in the chat a link to an excellent article on Philadelphia architect Lou Sawyer, whose really distinctive residential architecture is, I think, going to be considered historically important. There's a good article about that. I also want to alert you of two things that are coming up in the near future. On Monday, the Orphans Court will hear the petition from Drexel University to transfer the trusteeship of the collections of the Philadelphia History Museum to Drexel University. As you know, this has been a thing long in the making. The closure of the Philadelphia History Museum is something we all lamented. It's also something that only Drexel came forward with a concrete plan that would keep the collection together and in Philadelphia. And the judge in Orphans Court will hear that petition on Monday. A number of people have chimed in to say that Drexel should do more. I don't have any prediction as to what's going to happen on Monday with respect to that, but it does appear that there is really a general sense that this is the only way forward, the only viable way forward, at least in general terms. I also want to bring to your attention something that I just learned about yesterday. This trio of early 20th century buildings on Market Street at 23rd and Market are within have been surveyed as eligible for the National Register, but are not on the National Register. They're eligible to be on the National Register because they're in a district that was reviewed and studied by the Pennsylvania Historical and Museum Commission a couple of decades ago. But they're not protected right now. And they have recently been the subject of developer interest. In 2021, this was proposed and advanced through to the level of being accompanied by a community benefits agreement with the Center City Residents Association, a mixed use, largely residential, but with some commercial in it, which, as you can see, saves the facades. That project is now apparently dead, and a new developer has come on the scene, whose name you see up there, Tishman Speyer of New York, with Kieran Timberlake as the architects. Unfortunately, it appears that there is no preservation of the facades in this new plan. And this plan would be probably entirely for biomedical research, the new growth industry. So that is something that I will certainly be watching, and that I think DAG will want to keep an eye on as well. And I know that the Center City Residents Association is very unhappy with this new proposal. Here endeth my sermonette.
Thanks, David. So this is normally where I throw over to Marcia and she tells us about upcoming monthly meetings, but she is off having fun somewhere on vacation. So let me talk about, we have two really wonderful upcoming programs. In March 24th, Rebecca Chan, the executive director of the Rail Park, is going to be with us talking about some feasibility study work that they've completed and their plans for next steps, the future of the development of the Rail Park. So excited to hear more about that. It's a very interesting project with all sorts of challenges and hurdles, but a huge upside as it continues to grow. So we are looking forward to that. And then in April, we have Alexa Bossy and Ari Miller, who run Hinge Collective, are coming to talk about Philadelphia Tree Plan and getting perspectives on Philadelphians and getting trees to the people who need trees the most because of the wonderful benefits of being in a well-planted, well-treed community. So you can go get the whole 3-pack on our website right now. You can sign up for all 3 of those events, including the evening session next week to talk about streeteries. So with that, let's get into it. I'm extremely excited for this morning's program. I follow Christine Williamson on Instagram at Building Science Fight Club. I imagine if you're here, you probably do. And if you don't, you should go do that right now. Christine has spent her entire career in building science forensics, discovering why buildings fail, working with owners and architects and developers and builders to remedy problems. So follow her on Instagram. It's a really great way to see some wonderful, engaging content. And then, she's been the past chair of ASHRAE's technical committee on moisture management in buildings, as well as lecturing across the country at professional conferences and universities. So please, as you get questions, throw them in the chat. We will have time to do a significant Q&A, but I'm thrilled to welcome Christine Williamson.
Thank you so much. Thanks for having me. So I'm going to share my screen here, and let's make sure that this all works. Get this set up first. Okay, you guys can see that, I hope. Thumbs up.
Yes.
Yep. Okay. So what I'm going to do is I'm going to talk to you guys about why buildings leak, which seems pretty basic, but we'll get to that in a minute. And I'd like to talk for about 30 minutes on this, and then have a pretty generous amount of time afterward for question and answers. A lot of what I'm going to talk about is pretty familiar to you. I'm certain that it's familiar to you, although it might not be familiar to you as presented in this way. And I think it will give us some interesting things to talk about in terms of application when it comes to applying these principles to real buildings in real cities with real clients and real occupants. So with that, I can't see, I'm not going to be able to see the chat while I'm speaking. If something is burning up and you don't want to wait until the end, feel free to unmic and interrupt. Otherwise, after about 30 minutes, covering the sort of more formal part of this, I will look at the chat and I can engage with you there. I'd love for you to feel comfortable actually asking questions. I'm not a nervous presenter, so you're not going to throw me. The whole point of this is to learn and to talk things through. So please feel free to participate. This is definitely not a one-way street, and it's more valuable when you participate as well. So okay, so with that, why buildings leak? So understanding and avoiding water-related defects in architecture is our topic today. We're not going to be able to cover all of it in the 30 minutes that we've got allotted here, but I really find that in my experience in forensics that a lot, like 99% of mistakes that I come across in both design and construction come from a fundamental misunderstanding of how walls manage water. And I think that even those of us who are in the profession and sort of see this stuff day to day benefit from taking a step back and saying, okay, like what is the framework that we're working within, and being able to understand that ourselves and articulate that to the group of people. Design is collaborative. We were talking about this before the meeting. Being able to articulate these concepts to people who are less familiar with them, but who work on our buildings nevertheless, is really important. I had a studio professor in architecture school observe once. I hated a studio, by the way, but it's funny. I remember almost nothing else from it except his observation that architects spend their entire career communicating with people about things that don't exist yet. And that's a real challenge for us. And so communication is a big part of our job. Now, we know how to do this in a lot of ways visually, but that's not the only type of communication we're doing. So, all right. So with that, let's talk about how buildings actually manage water. I'd like to talk about the 3 approaches to water control in walls. So we've got storage, WRB and drainage, and exclusion. And storage is most common with mass walls. WRB and drainage is how framed walls manage water typically, and exclusion is how perfect barrier walls manage water. And we're going to talk in more detail about each, but storage, WRB and drainage, and exclusion are the 3 possible approaches that we're dealing with. So with respect to storage, the storage approach involves the wall absorbing water, redistributing that water, and then releasing it by drying. This is how mass walls manage water. The mass wall gets wet. It has an enormous capacity to store and redistribute that water safely. And then it dries in both directions. This works really well because mass walls are built out of materials that are not moisture sensitive or not very moisture sensitive. These walls have a very long history of performance, and indeed, many of the world's most beloved buildings manage water in exactly this way. Right. This is very common for us in especially in architecture. Most of our many of our favorite buildings work exactly like this. The classic example of this kind of approach to water management is the solid masonry wall right here in the middle. But masonry walls with stucco renders are also very common, even in new construction. So this is not so much in Philadelphia, but places like Florida. Coastal regions will do this. It's a little bit more common, even residentially. And then, of course, we have fairly common composite walls with combinations of different kinds of stone and block. These walls are very durable. They are also heavy, like they literally weigh a lot. And they also tend to cost a lot, in part because they are so heavy. We seal windows, doors, and service penetrations to the exterior surface. Our second category is the drained approach, the WRB and drainage. Drained walls have a cladding that sheds water and a water control material and drainage space behind the cladding to protect the rest of the assembly. The building code calls the water control membrane a WRB, or water resistive barrier, and we seal windows, doors, and service penetrations to that water control membrane. The idea with this is that we can build lightweight framed walls as opposed to those solid, heavy masonry walls. And we can build our lightweight framed walls out of materials that are moisture sensitive, like wood, if we protect those moisture sensitive materials from excessive wetting by having a cladding that sheds water and some kind of membrane behind the cladding to protect the moisture sensitive parts behind it. This water management approach is the standard approach in North America, and it's part of why building is so inexpensive here, relatively speaking anyway. Framed construction out of lightweight moisture sensitive materials is an extraordinary innovation. Really, I cannot emphasize this enough. It's remarkable. Now there's trade-offs with this. There's always trade-offs, but this is a really clever approach to construction. We can build out of lightweight materials. We can build out of moisture sensitive materials and still have a system that manages water effectively. The third approach to water management is exclusion. We call these walls barrier walls or perfect barrier walls. Windows, doors, and service penetrations are sealed to the exterior surface. This is the least common approach to water management in walls, and it's often the most tricky. I think I've probably worked on, throughout my career, maybe only 2 or 3 projects that managed water in this way. And actually, even on those projects, they were institutional projects, and part of the facade managed water in this way. And there were more traditional mass walls or framed walls for the rest of the building. The classic example is the Apple Store. So structural glazing can work this way. Insulated metal panels is the most common approach. So that's the context I've come across this approach most frequently for hospitals, that kind of stuff. There is nothing wrong with this water management strategy. However, its application is typically pretty narrow. And the reason for that is that most of the time, it's just not realistic to create a perfect barrier for water and still build the type of building we want to build out of the materials that we want to use. So most of the most popular building materials just don't lend themselves very well to perfectly blocking water and doing so throughout the entire service life of the building. Now, the issue with these 3 strategies, and this is why I started with this, comes when we mistake one of these approaches for another. We tend to really not like the results when we treat a drained wall as though it were a mass wall or a perfect barrier wall. And I think it's also really important to point out that this represents a significant difference in how a professional approaches water management in design and how lay people, including many of our clients, approach water management to the extent that they've thought about it at all, right? Most of them would assume that there's only one approach to water management, and it's exclusion. They don't understand how mass walls work. They don't understand how drained walls work. And this can make communication difficult. I think people outside of our industry, and in fact, unfortunately, some people inside our industry assume that we are in the water blocking business. And that is usually not the case. It's rare for us to be in this territory here. We are managing water. And that is a very, very important distinction, which brings me to the most helpful sentence in water management and in building science, I find. And that is this: for water infiltration to be problematic, the wetting a wall experiences must exceed its capacity to store and redistribute water for long enough to damage the materials that compose it. This is unbelievably important. And it is so important that I'm going to repeat it. And I encourage you to screenshot it, memorize it, whatever, meditate on it. Don't go too crazy though. But for water infiltration to be problematic, the wetting a wall experiences must exceed its capacity to store and redistribute water for long enough to damage the materials that compose it. This is helpful in that it kind of helps us understand our three water management strategies a bit better, right? Mass walls work because of their ability to safely store lots of water and dry out. Perfect barrier walls work by being perfect barriers and not letting any water in the very small assortment of designs and materials where that's even possible. But that middle strategy, WRB and drainage, is a bit more tricky. And those walls, which are the most common in North America, are walking this tightrope between wetting, safe storage, and drying. Now, that's true of our mass walls too, right? I've presented this as though we let these walls get wet and they dry in both directions and they're not moisture sensitive, so it works. That's true, but I mean, look at how our mass walls manage water. We do practice source control in mass walls. Typically, we have cornices, we have overhangs, we have setbacks, we have drips and kerfs. We do our best to reduce wetting and then make it so that the wetting that occurs is sufficiently, our wall can handle it. It occurs to a degree that the wall can safely absorb and dry in both directions. So we're really always dealing with this rate of wetting, rate of drying, and safe storage capacity with all three of these strategies. But the safe storage capacity varies, and the rate of wetting varies, and the rate of drying varies. And that's why our jobs are hard. That's it right there. It's not, this isn't a pass fail thing. This is a balance that we're trying to achieve. And that's difficult to contend with a lot of times. So let's talk a little bit more about this middle strategy, specifically as it relates to leaks. And I want to talk about what actually constitutes a leak. So a leak requires four things: a source of water, a pathway for that water to travel from where it is to where we don't want it to be, a driving force that pushes water along that pathway, and then something for that water to damage or someone to be annoyed by the damage or by the water, by seeing the water. Those people are clients, occupants. So what's interesting here is that we require all four of these elements to have a leak. This is very helpful for us. Although, a leak seems really obvious when you first approach it, right? It's water where you don't want it. It's pretty simple. Nobody stands, bucket in hand while it's raining inside, wondering like what a leak is. But as professionals, when we seek to avoid leaks in the first place and diagnose them and repair them once they've occurred, understanding these 4 elements is extremely helpful, because it means that we might have more resources available to us than we first expect. So we need a source of water, a pathway for the water to travel, a driving force, and something to be damaged. We spend most of our time here in the focusing on pathways and sealing pathways. And that's not bad, that's not wrong, but it is not the only approach. And what we tend to underestimate, I mean, like crazy underestimate, is the effectiveness of this source control and this dealing with our driving forces. We're going to talk about that in just a moment. So let's talk more specifically about each of these 4 things. So sources, pathways, driving forces, something to be damaged. So common sources, pretty straightforward, right? Rain and groundwater. Common pathways, also pretty straightforward. We've got joints, transitions, penetrations, we've got windows, we've got doors, we've got service penetrations, fasteners, thousands, tens of thousands of fasteners through our water control membrane in these types of assemblies, right? We've got the fasteners that hold the sheathing in place, the fasteners that hold the cladding in place. We've got lots and lots and lots of fasteners, in addition to the penetrations that we design for on purpose. Common driving forces. Some of this is obvious, some of it is less obvious, and we'll talk about some of the less obvious ones in a little bit more detail in just a moment. We've got gravity, hydrostatic pressure, wind, momentum, capillarity, and surface tension. And we'll talk about that in a moment. But these are the forces that move water from one place to another. So again, it's not enough just to have a source of water or in a pathway. We have to have some kind of mechanism that pushes water along the pathway. And these are those forces. And we'll talk about the application of that in just a minute. Common materials at risk of damage. This is pretty intuitive. Anything moisture sensitive that we put in our buildings or use to build with. So wood-based sheathings, trims, floorings, insulations, paper-faced gypsums. We have no shortage of things that can get damaged from water. Sometimes we can do something about leaks in this way, right? We can use less moisture sensitive things to kind of take the edge off of the consequences of water problems, but often our hands are kind of tied here. We have to do a better job at these 3 things. Although, I mean, an example of that would be, so using plaster instead of paper-faced drywall for something, or using gypsum or a glass mat faced gypsum in hospitals, for example, rather than paper-faced gypsum, to reduce the risk of mold in the event of high moisture conditions. So there's some place sometimes, but oftentimes not. So we're going to focus our attention here. Okay, so common pathways, we talked about these. We don't have to picture them, although I will show you some. So fasteners that hold the WRB in place, fasteners that hold the sheathing in place, fasteners that hold the cladding in place. Most of these are not sealed. We do not seal these. You could, I mean, some of them you could seal every one of your brick ties. I don't think you should, but you could, a lot of times our claddings are blind fastened. So we can't even see them to seal them if we were to seal them. Brick tie, what it looks like. Some people don't know. Okay, so let's talk about this second category, or this third category here, common driving forces. So gravity is pretty obvious, right? If we've got a horizontal surface, like a low slope roof, and we have a hole in it, some penetration wasn't flashed properly, or a skylight wasn't detailed properly, and then it rains, that's pretty obvious. The force that drives water along that pathway is gravity. So we get that, but some of these others are a little bit less obvious. So let's start with surface tension. This is the tendency of water to stick to a surface. The most common architectural example of this is water tracking back horizontally along a soffit or some architectural detail rather than dripping straight down due to gravity. And typically this isn't a mechanism that causes most leaks, like when we're talking about real failures here, of that kind. But we tend to care a lot about surface tension when it comes to stuff like staining. This comes into play. The next driving force that's a little bit less obvious is capillary movement. And it is the movement of water within the confined space of a porous material due to the attractive force of surface tension. So it's actually capillary action is a form of surface tension. It's just a form of surface tension in very small spaces. So an example would be to dip a paper towel into a cup of water and watch the water wick through the paper towel. The same thing happens with all kinds of building materials, particularly cementitious building materials like brick, stucco, concrete, mortar. Incidentally, it is also what brings water up to the tops of trees, right? So probably the first time you learned about capillary movement was in maybe elementary school, in learning about how photosynthesis and trees and all that kind of stuff. So water from the ground will wick up through the roots and the trunks and the branches all the way to the tops of trees. I find that thinking of trees is particularly useful when thinking about capillarity, because not only do we build with wood, we also intuitively know that trees can be very tall, which is a powerful indication of the magnitude of capillary transfer. We should not underestimate this. This is a very effective way of moving water from one place to another. And it's very common in the materials that we build with. The big money one, this is the concept that I wish architects had a really good handle on. I think it would help them a great deal professionally, is hydrostatic pressure. And it is an extremely important transport mechanism for liquid water. And you'll want to take some time to understand this, but it only seems complicated, don't worry. So hydrostatic pressure is actually, it's really gravity. It's just sort of a special kind of gravity. It is the pressure that water exerts against a surface when it is held up against that surface. And the classic example is a lake and a dam. And I'm showing you a picture here of the Hoover Dam as an example. The dam holds water back, and the water in turn exerts a pressure, horizontal pressure against that dam. But the pressure on the dam isn't the same at every spot on the dam, right? It's we already intuitively know this, right? The pressure down here is going to be much, much greater than the pressure up here. And in order to determine like specifically what that pressure is, there is an equation. You will not have to do math, but it does benefit you to see the equation. So pressure, that pressure at any given point on the dam, is equal to the density of the fluid times the acceleration from gravity, the gravitational constant, times the height of the column. So where we are vertically on that dam. And you will notice that this is kind of an interesting thing here, in that two of these things, at least here on Earth, are the same, right? We know the density of the fluid that we're most concerned with is water. We know the density of water. We know the gravitational constant. So the only variable in this application that really varies is the height, is where we are on the dam. And what's kind of neat about that is that so the pressure is entirely dependent on where we are expressed vertically. So the size of the lake doesn't actually bear on the magnitude of the pressure at all, but the depth of the lake does, which is crazy, right? Now, in buildings, well, in most applications, the volume of water that we're dealing with obviously matters, right? If you have, if you can have and if we go back to our leak here, we can have a source of water, a pathway, and a driving force. We can have all three of these things. But if the source of water is very small, if we have a pathway and a driving force, but like our roof leaks, say, a skylight that hasn't even been finished yet, and we get a very light, very brief rain, that's obviously less of a big deal than if we get a downpour. So the volume of the lake here does end up mattering to us, but it doesn't affect the magnitude of the pressure. It's just the height. So what this means is that the pressure that Lake Mead exerts on the Hoover Dam, 1 inch below the surface of the water, is the same as the pressure that my water exerts on the plastic bottle 1 inch below the surface. Isn't that crazy? It's kind of nuts. That part's not intuitive to me. But anyway, okay, so architecturally, how does this end up mattering to us? It matters in stuff like this. And this is where we'll come back to our drained well in a moment here. But when we have a cladding and a space behind it, and that space is for some reason clogged up, we allow water to become what's called perched against our water control membrane. And when we do that, hydrostatic pressure, and the more water we allow to become perched, the more pressure driving that water to the interior there'll be. We permit a driving force, or we provide a driving force to bring water to the interior of our buildings. So in this example, we've got a masonry veneer with a very standard residential 1 inch cavity behind it, with a mechanically attached water control membrane. And then presumably, you don't see it in the photo, but we can presume that we've got a wood-based sheathing like OSB, wood framing, cavity insulation, and painted drywall on the interior. So we have all of these things in that example. We've got a source of water, rain. We've got pathways. What are our pathways? We've got capillary, or we've got porous materials here that have pathways. Then we've got you can kind of see the cap nail that's holding the sheathing in place. And we don't see it here. I think maybe back here, there's brick ties as well, or other pathways. And then our driving forces are capillary action through the brick itself and through the mortar will deliver water from the face of the brick to the back side of the brick. And then we've got this mortar in the middle here that does two things for us. One, it's a medium for capillary flow. And the other is that it allows water to become perched and produces hydrostatic pressure, driving water to the interior. And then, of course, we have all kinds of things that can be behind the WRB that can be damaged as a result. So yes, we have a problem with this. Will this well fail? Yeah, this one, I took this picture in Louisiana where I hear it rains a lot. But it rains in a lot of other places as well, right? And how bad will this fail? Will it fail every time? Maybe not. This is a 1-story house. It's got an overhang. Probably nobody will know it will fail and will leak, but probably nobody will really know about it for some time. And the easiest thing that we could do to make this well work is, of course, to make this space actually clear. It's really hard to do that residentially when we only have a 1 inch cavity. Commercially, let's see if I have a picture of a commercial wall. The cavities tend to be larger, 2 inches. And in my experience, it's pretty reasonable to ask a mason to keep a 2 inch cavity clear. They can do that pretty well. But in residential construction, keeping a 1 inch cavity clear is very, very difficult. So I recommend that all my clients use either a drainage mat in there, most typically, or a textured building wrap or something else to give us a little bit of a space for drainage and drying. Now, I'm going to show you some examples of what very quickly, because I want to leave lots and lots of time for questions. I'm going to show you do 2 more things with you and then questions and discussion, not just questions, discussion too. But I'm going to show you some examples of what stuff looks like when it fails. And then I want to talk about our 3 strategies again in the context of what we've just gone through. So this is what insufficient drainage and drying looks like. This is a townhouse in Houston. It used to have a stucco cladding on it, and there just wasn't enough drainage. It was a code compliant building, just not enough drainage. It was so wet, and this was after approximately 5 years. It's pretty just disintegrate. This was not a leaking window. This problem was not how the window was flashed or installed. Problem was insufficient drainage. single family home in New York, same problem. Not leaking windows. There's nothing wrong with these windows. It was just insufficient drainage behind the stucco. This one is kind of a crazy project. I don't know how much I can say because I'm being recorded, but whatever. These people probably don't notice it. So this is not my project. This was a multifamily apartments in Dallas. My dry cleaning is close by, and I watched them take this building apart and noticed a very familiar problem. So the sheathing was completely rotten, and you can see, this is a closer view. You can see a little, this is the clearly visibly wet OSB sheathing and a tiny little square of building paper left over. I've been using this example to teach with for a long time, and I actually ended up socially meeting the owner of this. And what's crazy is they went back, because my dry cleaners there, I kept track of it. When they were repairing it, they repaired it with the same system that that failed, with insufficient drainage. It was the building code requires only 2 layers of building paper, and that is not enough drainage. So the first layer of building paper required by the code is the water control layer. And the second layer of building paper is designed to give us just a little bit of a gap for drainage and drying. That's a huge source of misunderstanding, by the way, in our industry, where we sort of assume, oh, well, we have all these failures. It must be that the water control layer there's something defective about the installation of that WRB. There's nothing wrong with the installation of the WRB. It's this. It's driving forces. We have a water control membrane that would work fine. And in fact, there is no commercially available water control membrane that is robust enough to resist hydrostatic pressure. We have to do all of these things on this list. We cannot just do one of them. Dealing with the driving forces is part of our responsibility. Our WRB cannot work properly unless we deal with these driving forces. So these two layers of building paper, we don't have the second layer because the first layer isn't up to the task. We specify the second layer to deal with the driving forces, to give us a space for drainage and drying. And that brings us to, I guess, right back here again. I'd like to point out here that one of the biggest things that people miss with these 3 approaches, and in particular this approach, this drained approach, is that they fail to see this as a system. This is a system. Our WRB is not designed to work by itself. This is a system, and the system depends on having a water control membrane, an airspace for drainage and drying in front of it, and a cladding that sheds water. All 3 of these things participate in the water management of the system. The WRB isn't there because our cladding isn't up to the task. These failures here are not installation failures from crappy stucco installers or whatever the cladding system is. Cladding isn't designed to be a perfect barrier to water. In a drained assembly, we're dealing with a system. And the paying attention to each component of the system is extremely important. And that's really what I want to leave you with. I think the most natural, practical application of this. So now I've taken you here, and the first thing I would ask anyway is, okay, so I know I need a WRB. We got that. I know I need a space for drainage and drying. How big a space do I need? Now that is a much more complicated question, and it's one that we don't have time to fully explore. So I'm going to give you some rules of thumb to help. I recommend. Let's see where I do this. Give me just a moment to summarize it for you. Find the slide that summarizes it for you. Yeah, maybe I haven't. Yeah, here we go. Okay, so how much of a gap do we need? In climates that receive 20 inches of rain or more per year, and on buildings that are more than 2 stories, I recommend a space of about 1/4 inch, a clear space of about 1/4 inch behind reservoir claddings like brick, stucco, and adhered stone. Reservoir claddings are those claddings that hold a lot of water. So vinyl siding, for example, is a non-reservoir cladding, or a metal panel is a non-reservoir cladding. But cedar would be a reservoir cladding. Any kind of unpainted wood would be a reservoir cladding. 3/16 inch gaps work nicely on lower exposure buildings and on non-reservoir claddings, so panel and lap sidings. And in buildings with exterior insulation, I recommend a 32nd of an inch behind the insulation, or using a drainable insulation, and an 1/8 to 1/4 inch in front of the insulation. This is my general rule of thumb. This is a more complicated question, and I'll tell you why it's more complicated very, very briefly, is that we don't actually need a very big space to deal with hydrostatic pressure. We need a very small space. What we tend to need when we need a bigger space, it's actually usually for drying. And when we have reservoir claddings, what we like to see is drying into this cavity by both the cladding and the wall. And a bigger cavity provides more drying. And there's a few factors that affect, again, we don't have time to explore all of the options here, but that's why reservoir claddings tend to require a larger space, because we want to dry them out into the space before the sun comes out and drives all that water vapor into our walls. But again, that's for another day. What I really want to leave you with is the importance of understanding our 3 approaches to water management: mass walls, drained walls, perfect barrier walls, understanding them as a system of water management that is dependent on exactly this, on the rate of wetting, the rate of drying, and the capacity for safe storage. And achieving the right balance requires attentive design and a nuanced understanding of this approach, of how our walls actually perform in service. And with that, I'd love to open it up to, I'm going to stop screen sharing. I might share again if you guys have certain questions, but I'm going to do that so that I can look at the chat. And actually, like, Eli, maybe you want to MC this section here. How do you want to handle discussion?
Absolutely, I'm happy to. I think one question that was coming up was about, that you started to talk about at the end, was exit strategies, and in addition, how do you get drying? You talked about both top and bottom. Can you talk a little more about those exit strategies and approaches for that?
Sure. Yeah. Okay. So and now I will share this again. Okay. Let's do this. See if it's exactly where it is. Yes. Okay. So we've got a space behind our cladding for drainage and drying. Well, now what do? Now we've got this clear space. How do we actually get that water back safely to the exterior? And we provide what's called through wall flashings. And let's see if I've got an illustration of this. I sure do. The detailing of this is going to be dependent on what you're using as your WRB here. Don't pay too much attention. So the layering would be inappropriate if this were a building paper, but I'm assuming a fluid membrane here. Don't pay too much attention. But what we want is some way for water to drain from this cavity to the exterior when we have a brick veneer. And this is going to be dependent on what kind of cladding you have, right? But when we have a brick veneer, we provide through wall flashings. So this is my favorite approach to doing it, is to have a metal through wall flashing here, a combination of metal and membrane. So I have this membrane here that strips in the flashing to the face of the water control membrane, and I let water drain out. And then this little X'd out brick is what's called a weep and a vent that does both things. It allows water out. It also allows air in. This is what it looks like when it's installed. So this is our metal through wall flashing here. And then this is our weep that we've put in the vertical mortar joints. And you'll notice that the weep is all the way at the bottom, which is good. This is not good. I mean, it's not terrible. It's not completely tragic, but why don't we like this? We don't like this because we need water to accumulate like a 1/4 inch, producing hydrostatic pressure. before it can drain out safely to the exterior. This is unlikely to cause a leak though, because we're usually pretty good at detailing the rest of it. But anyway, all things being equal, that's what you want to do. Typically we don't do this, or I mean, this is not rare, but it's often, I often see through wall flashings not handled with the care that I see here. So residentially, we see a lot of this, where you get some weeps and you're using this, whatever this is, polyethylene, or sometimes it's visqueen, some sort of plasticky material that doesn't bond super well to the mortar, so you get a little bit of drainage there. And this will drain, but it's pretty sloppy, and I don't like relying on. It's just sort of sloppy. It does work, but it's sloppy. People also tell me they don't like. A lot of architects are like, I don't like the look of this. It's so industrial, and I agree. I don't like the look of this either. But compared to what? Like most of the time, we're not actually doing anything. Like compared to this is what, like, and we don't look, if you actually start looking at this stuff, there's like so much ugly stuff out there. We just don't see it because there's shrubs here, right? Anyway, but the joke is that the worst, that's not the joke part, but the worst through wall flashing is no through wall flashing at all. And the joke is weep now or weep later. Sort of cheesy. But you can see here, there was no through wall flashing designed in this wall. Now this could have been, so if you see stucco, you don't know this looking at the photo, but I can tell you this. This is a framed wall. Stucco sometimes, if we had a stucco render on a masonry wall, we wouldn't need through wall flashing in the same way. That's not how the wall manages water, right? It's not drained. This is a drained, or should have been, it's designed as a drained wall without the through wall flashings. And you can see that water is finding its own way out. And that's the water that's finding its way out. There's a whole bunch of water in this building. This is a house that did not find its way out. Guess where that water is? It's rotting and molding that house. So yeah, weep now or weep later. But there's stuff to be done to make this more architecturally appealing. You don't have to use stainless steel. You can use other metals. You can use painted aluminum. You can use copper. There's ways of designing this to make it look less industrial. But for goodness sake, we can do better than this and this. The second part of this, so that's getting water out from behind our claddings. Often this is really easy, like with a panel siding. The photo is a little bit washed out, but this is a panel siding and a drainage mat behind it. And it's just a little bitty metal, through wall flashing piece with a drip that lets water out. It's very subtle. You barely see it. And that's this here. When the next panel is installed, I mean, it's you have to be a real geek and looking for it to even perceive that it's there. With stucco claddings, I don't like to rely on the weep screed because it gets filled with mortar. So I treat the weep screed just like a cladding termination, and I have a separate through wall flashing here. I mean, you have to get, I didn't like taking this photo. I had to get on my belly to take it. So it's, these things are usually pretty subtle. Or this one doesn't even have a drip edge. It has a drainage mat behind the weep screed and it just drains. We're not dealing with a lot of water. We're dealing with enough water to damage our wall, but not enough water. Like we're not gushing out here. So we just need to take the edge off. And then of course, at the top of the wall, I don't have an image to show you, but I do have a sketch. The best approach is to not just provide weeps, but to also provide vents. So providing some sort of air outlet at the top. Now in brick, we use the very same weeps that we use for drainage are also vents, and we put them in the top the same way. It's pretty easy, very subtle, but there's lots and lots of ways to approach this with other cladding types. A lot of times it happens with us not even specifically designing it. We only need very small spaces to get good air exchange behind many of our claddings. Like a 1/16 of an inch, a 1/4 of an inch. Like, we don't need a very big space to make this happen. We just need to take the edge off. The critical part is making sure that this space is clear. That's where we tend to struggle the most.
So a question about the code. You mentioned the project in Dallas that was code compliant, yet the system itself was
That's the code
insufficient.
in Philadelphia too.
So how does that code change? What kicks off a code change that could update
Okay,
that?
DAG, I'm counting on you. Come help me. Code hearings are open to the public. Anybody can pass a code amendment, make their case, and have it, there's public comments, and then it gets voted on and adopted. So this is something that I would like to see changed. My term at ASHRAE just finished, and so my new professional, I was with ASHRAE served on a committee for about a decade. And so my next challenge is exactly this with respect to stucco. I'm proposing it for you in Philadelphia as well. And you as a city can make changes, your own amendments to codes as well. And so I'll give you a very brief overview of where the code is right now, the challenge with changing it, and what I'd like to see happen instead, just really quickly. So the code currently requires 2 layers of building paper. And there's a few, generally, there's some, building codes are complicated, but basically it requires 2 layers of building paper. The first layer is the WRB. The second layer is the space for drainage and drying. We don't need a very big space in a lot of places, but we do need it. We've discovered through failures, and there are, multi-million dollar, $100 million class action lawsuits all across the country related to this now. We saw this problem in Canada a little bit sooner, where the problems in the 90s were so bad in Western Canada. You can actually Google this, leaky condo crisis. There's a Wikipedia page, and it had to do largely with poorly drained cladding systems. And it was so bad that it bankrupted the mandatory warranty programs in Canada. So this is not a new problem. We've known about this for a long time, but this is like turning the Titanic. This is very hard to actually get done. And a lot of people have competing interests in this. So what's happening now, as we seek to make code amendments to require additional drainage and drying, we get pushback from different interest groups. So one are the big one that's influencing this right now are materials manufacturers, who want to gain a competitive edge by writing the rules in such a way that favors their product over their competitor's product. And that's the biggest challenge we're seeing right now. An easy solution behind stucco and adhered stone is to require drainage mat. But in climates that receive 20 inches or more of rain a year, of rainy climates, sorry, I'm getting excited here. But that's expensive. I mean, it's not that expensive. So I recommend it on all of my custom homes. Drainage mat is about $1 to $1.50 a square foot. It's not that expensive. So anybody who's hired an architect and gone to the trouble of working with me can work this reasonably into their budgets, in my opinion. But we don't write the codes for wealthy people designing custom homes. We write the codes for everybody. And do we want to overcorrect by requiring a full drainage mat or that big of a gap? The Canadians said, yes, we do. And there's some other politics in Canada that influence that as well. But we don't, from a technical perspective, quite need that much room. We can split the difference by using a textured building wrap if we also provide vapor control. And again, this is a more complicated argument. So you know how the code currently requires 2 layers of building paper. We could still require 2 layers of building paper if one of the layers were textured, were somehow crinkly or something, and they make textured building wraps. And if one of the layers also provided vapor control to reduce how much water vapor enters the wall. Now, the problem with that is some of the manufacturers who make textured building wraps don't also make textured building wraps that provide vapor control. And so they want to, that's where this fighting is getting into. So they have all this really dumb stuff about, anyway, it's hilarious. If we were having this conversation with over beer after work one day, I could tell you some fun stories about the ins and outs of some of this stuff. But that's the broad overview of the debate. I hope I propose this for Philadelphia. So you have an opportunity to do this before the 2024 code iteration. And if it gets good support, I think it would be great. And that's my proposal, is two layers of building paper, one of them textured and the other one providing some form of vapor control, or one or the other providing some form of vapor control. It's as manufacturer neutral as possible. And it gives architects and contractors as much flexibility in picking how they want to address this issue. It gives them the most flexibility. You can use drainage mat, you can use any textured building wrap that's commercially available right now, plus something that provides vapor control, like tar paper, like the totally standard black building paper. Like, it's a commodity. It's not an expensive solution, but as you know, things take on a very political turn. I once did an investigation on a big project. It was a tower project, very tall, and they were getting, I can't believe they were using stucco on this in the first place, but it started leaking immediately. They hadn't even finished it. They were wondering, they couldn't proceed with insulation and drywall on the interior before the building was dried in. It kept getting really wet. They had a very dumb detail that was responsible for much of this. But the second part was that they were using stucco with poor drainage behind it on this really highly exposed building in a wet climate. And they had done about 20, maybe they'd done like 15 of 35 stories. And roughly, I don't remember the specifics anymore. And I recommended that they immediately add drainage mat to the remaining stories. And they elected, even though they knew, and I think they were persuaded on the technical merits, but they elected not to, because then they would have to justify why they didn't do the first 15 stories that way. So they were making basically a legal decision, not a technical decision. And they were doubling down on a bad decision that they knew that they could correct, because they didn't want to, I guess, incur liability for the lower floors. Whatever, they didn't explain it all to me. And what do I know? I'm just the technical geek that comes in and tells them what to do. But as you know, there's lots of interests at play, and they don't all align in such a way that produces the best building.
So let me ask you a question. This is from David Gargano, who's saying, you talked about communication at the beginning. What is your recommendation on how to best ensure PMs, and I'll add construction managers as well, properly communicate the crucial component system details to any subcontracted installers?
That's very hard. And I don't have a magic answer. I think investing in this type of information ourselves and being able to clearly communicate it ourselves is a good first step. There are a lot of industry resources out there, but we get lost in it, right? Like, a lot of the info, I didn't invent what I presented to you today. But there's a lot of crap out there. There's a lot of HGTV drivel. There's a lot of temptation to focus on like every part of the building except how it actually works. The building ends up becoming incidental to us, and how it manages water is incidental. We're looking at finishes, we're looking at profit margins and price points and what we can sell. And I'm not saying that those other things aren't important. They obviously are. They're interesting to a lot of people, but I think that's part of why we have such a problem, is that those things are really appealing, and we like to think about them and sort of think about this other messy stuff with managing water only as an afterthought. So I don't know. I don't have an answer. Do the best you can. The contractors, I guess maybe if there's one thing I can say, is that treating continuing education as an investment is a pretty good like cultural attitude that organizations like DAG, but all of the professional associations can be better at supporting. I think this is sort of as much a cultural issue as it is a technical issue. And that if we have a culture of craftsmanship and caring and treating ourselves, regarding ourselves as professionals, that are continuously investing in our own education and craft, I think that helps things a lot. But that's not just okay, well, we pass a code change or something. That's a cultural change, and it's how do you change a culture? I guess one person at a time.
So Alan Pierce, do you want to unmute? There's a really interesting question here about mass walls, but it's long, so I want to make sure you can ask it and give it the right tone. So fire away.
Sure. So, hey, Christine. So we deal a lot in Philly with historic mass walls where we're trying to insulate from the interior to preserve the exterior. And the detail we've used in the past is either a liquid applied on the interior face of the masonry or a closed cell insulation, spray insulation. And I'm just wondering, your diagram indicated the mass wall needs to dry to both sides. So is it okay that we're sealing one side of that mass wall?
Sometimes you are asking a really hard question. And I often really, just in general, I often don't present on retrofits for exactly a reason that you're highlighting here, in that it's every retrofit you do, particularly with these masonry buildings, these energy retrofits for masonry buildings, requires an enormous amount of experience and professional judgment. It's not a pass-fail criteria. With respect to the specific question you've asked, yes, what we're doing is we're reducing, when you insulate a mass wall on the interior, you are reducing that wall's ability to dry into the interior greatly. Because we're reducing the energy flow across the wall, which is exactly what our intent, right? We want to make something more energy efficient. We want to make it more comfortable for occupants. So can the wall handle that? And the answer is it depends on the wall. And so what's maybe misunderstood about that is when you're assessing, like, okay, am I going to be able to do this safely and properly? What you end up having to assess is how good that facade manages water to begin with. So is it a building and like, what is the condition of the masonry in now? So does it have cornices? Does it have setbacks? Does it have curves? What kind of masonry is it built with? Some stuff you can see, I don't have images to show you now, but there's a lot of masonry that's really showing its age and clearly isn't managing water very well to begin with. So do you have to make improvements to the facade, to the way the facade manages water, before you can consider insulating on the interior? Now, sometimes it's very obvious, like you've got a building that's in fantastic condition, and especially the historic buildings that people put a lot of thought into, like all those classical details are great water management details. And a lot of those buildings they do great, and they absolutely can be safely insulated on the interior. But it's hard to tell. There are two people that I like in this area who do excellent work that you probably, since you do this work, you probably already know them. But if someone's interested in doing this work or just getting started, I recommend looking at the work of Kota Ueno, I'll type it in the chat actually. Kota Ueno. Kota is awesome. And he's at Building Science Corporation. He's done a lot of this work. He's published a lot on this. And if you just Google his name and masonry retrofit, a lot of cool stuff will come up. And I'll introduce you to other people who are doing cool work as well. If you can catch a lecture or something by Kota ever, you will be richly rewarded. He is the closest thing to a computer I've ever met. Like, he is so smart. He is so smart. And anyway, so he knows a lot about masonry retrofits and does great work in that area. And the other guy, from a practical perspective, who practices in New York City is Peter Marciano. He doesn't really publish anything. He's a practitioner and does a lot of just has enormously great experience, like on the ground, just in fact, retrofitting masonry buildings from the interior. And he does them the way you've described with a fluid membrane. Actually, he tends to not use spray foam. But I prefer using spray foam. I think it's less dependent on labor and workmanship, but he'll use a fluid membrane on the inside face of the masonry, address whatever water management issues are going on the exterior. And then he'll insulate from the interior and also provide air and vapor control using typically smart membranes on the interior. I wish I had something better, but those are some good resources for you.
Libby Cook, do you want to jump in since we're in mass wall land? Do you want to jump in and ask your question? So while Libby is unmuting, the other question about mass walls was related to bare brick walls that have been stuccoed, and what do you recommend, and what can people do if they have a home, I'm guessing, that has been stuccoed, causing cracks, causing damage to those bricks behind that stucco layer?
Okay, so it depends on it depends, right? It always depends. Are we dealing with a full mass wall that's been stuccoed, or just a veneer that's been stuccoed? Stucco is actually a really fantastic water management tool. So historically, I'm going to share my screen again. So there is absolutely nothing wrong with this. And often we put stucco renders on solid masonry walls. You see this all over Europe, and they're doing it as a water management tool. The stucco is essentially, they'll put the stucco on the solid masonry wall, and it's essentially, and they'll use less expensive masonry. So we picked the stone specifically for this very special building. And we want it to look amazing, and we want it to look like this forever. But a lot of masonry buildings, we just need it to stand up. They're not churches, they're not museums, they're not art galleries, they're not these institutional buildings that we're investing in that way. And as a durability measure, we'll put a stucco render right on top, and then we'll redo the stucco all the time, every 20 years, 30 years, 40 years, whatever it is. And there's nothing wrong with that. And painting it, painting the stucco as well, reduces how much, it reduces how wet the wall gets in the first place. So suppose you had a masonry wall that was in bad shape and you wanted to insulate it from the interior, but you were worried about how it was managing water on the exterior. One strategy would be to reduce wetting by applying a stucco render as part of your retrofit. Now you can do that. You can put a stucco render on a veneer wall as well, and it will reduce wetting. Particularly if it's painted, it will reduce how wet the wall gets in the first place. And this is what we're doing, right? We're wetting, drying, and safe storage. But you can't just reduce the wetting typically with a veneer wall. You still have to address the underlying issue of drainage behind your veneer. So it depends on what the stucco. So the question is, it depends on which of these. Is this a mass wall that's got stucco, or is it a veneer wall that's been stuccoed? If it's a veneer wall, yes, your stucco might take the edge off of some of the wetting, but it's still a reservoir cladding, and it's still a drained assembly that depends on having a space for drainage and drying behind it. This is a really hot topic in historic neighborhoods too. So I live in one, it's a historic neighborhood, and there's always these people that lament anybody who ever, and I think it's outlawed in my neighborhood. My house isn't brick, so I haven't really paid attention, but the people who will lament painting brick, and they'll say that it's bad for the brick. It's not bad for the brick. I mean, you might not like it, but that's a different argument. It does reduce, if you paint brick, it does reduce how wet that brick will get and how wet it will stay. And you have to use, if you're going to paint the brick, you have to use a vapor open paint, because your paint will not be perfect. You will get water behind your paint, and it will need to dry in both directions. And when it dries out, it will blister the paint or the coating or whatever it is, if it's too vapor closed. Now, if there are other reasons to have this debate, if you start painting something, or if you start stuccoing over something, well, now you've created there's a new thing that you now have to maintain. And that may not be desirable. It might change the character of the neighborhood in a way that you don't like. There's plenty of other reasons to debate this, but as a water management strategy, it can be very effective.
So getting to Libby's question on 18th and 19th century buildings, I wish Zoom didn't move the chat every time the screen stopped sharing. So looking for resources as for studying 18th and 19th century buildings that have been documented with leaks. Any books, articles, sources to talk about how water and large scale, specifically brick buildings, interact?
Not offhand. How I would go about answering that question is I would call CODA, CODA Ueno. I'd start researching there to figure that stuff out, but that is not my specific. I mean, obviously the physics is the same, but there's patterns and there's stuff that we can recognize in common practices that I'm not as familiar with in that area. But it takes, each one of those is, I mean, this is true for all buildings, but I think especially true in this case that every building is a prototype. It's a one-off. And as professionals, it's helpful to have these rules of thumb, but this is an area where preserving these old buildings. So I have a whining dog. I hope she's not too bothering everybody too much. Hello, sweetheart. But this is an area where there isn't a shortcut. It requires professional judgment and sensitivity. And this is why you hire a competent and experienced team to approach these questions with sensitivity and sound judgment. It's hard. I saw a question right before Libby's. Do you like siloxane as an exterior brick sealer? Yes, but only as a last resort for sealers. If you're going to paint your brick or otherwise seal it as a water control strategy, you're introducing something that has to be continuously maintained. And it's very hard to do that on a lot of projects because you often can't see it degrading. Paint you can, right? But with these clear sealers, you don't, they're exposed to a lot of UV, they fail quickly. Like, how do you know what schedule you need to maintain that on? How do you know exactly how effective it's going to be? It's kind of a gamble. So I really only tend to recommend them as a last resort.
Jonathan Price, you want to jump in and ask a question?
I can hear you, Jonathan Price. I'm just going to move my dog to a more comfortable location. Hold on.
No problem. On cavity walls, do you recommend the cavity extend down to the horizontal leg of relief angles above windows, to keep the cavity clear?
Oh, so yes, you end up, that's the most inconvenient part of cavity walls, is detailing windows. Because when you have any, or drained walls, when you have any kind of drained assembly, if you're designing these old historic buildings, it's pretty easy. So I come across this a lot when I'm dealing with European window manufacturers, especially high-end window manufacturers. They get really confused by questions that we in North America ask them when we're using their products. So we're like, how do we detail your window? And they're like, I don't know, just seal it, right? They don't know because they're used to installing them in mass walls. Well, if you have a window in a drained wall, detailing the window isn't that hard, but it's how do you have to drain the wall above the window. And yeah, that gets complicated. So yes, there ought to be a provision for drainage above windows. And Often that happens at the relief angle or angle iron or whatever it is supporting that cladding. There's a gazillion variations on that though, and it can be very tricky. It takes us a
Thank
long
you.
time.
It can be a challenge when the cavity is fairly large because it introduces torsion on the angle.
Exactly. Yes, it's difficult. Yeah, I don't. It becomes increasingly difficult when we want to fill that cavity with insulation. So this is another area where we're balancing a lot of competing interests here. So I showed you this. Share the screen again. I showed you this earlier in commercial construction. So commercial construction, our code requires 2 inches. Wouldn't it be nice if we could use some of that real estate for insulation? Because if we now, let's say we want to add 2 inches of exterior insulation, and now we also have to have 2 inches of cavity, we've got 4 inches. So now we're offsetting our brick, not just at our windows, but like everywhere. That's really expensive, and it's a huge thermal bridge. So we don't really need, the code says it, and it's sort of a moot point for us now because we're not using very much continuous exterior insulation. But if we could reduce this cavity to 1/4 inch and use the rest of it for insulation, we would be minimizing that the structural requirements that we need to offset our cladding that much. But yeah, that's going to be the question. Like your question is going to be, I think, a big issue for us as we start moving into like using continuous exterior insulation is going to put that question at the forefront. Because we're so used to this. We don't need 2 inches for drainage and drying behind brick. We need vapor control. We need maybe a 1/4 inch, both for drainage and then for tolerances. We want to be able to get that brick flat, but we don't need the full 2 inches, and it's expensive. It will become increasingly expensive to get that later. But our codes weren't anticipated. They're cumbersome. They weren't made to be super flexible. It takes time to change this stuff around.
Thank you.
Actually, while you were sharing, Richard Gliniak, did you get your question answered in here, or is your question still outstanding?
Well, it definitely got a start. I'm seeing so many stucco bays in my neighborhood, which is the Graduate Hospital area where homes were built here 10, 15 years ago. And they're all being taken down, the stuccos, but nobody's putting the stucco back. They're putting Harding board up. So I'm still at a loss, like, where did these stucco jobs go wrong? Because they didn't have the proper drainage behind the stucco?
Correct. So the problem is not the stucco. It's not the workmanship. It's not the stucco works. The stucco works fine. The problem is that there wasn't enough drainage behind the stucco. And they were, some of them are too old for this to have happened. We introduced the 2 layers of building paper requirement, I think in around 2000. So if these homes were built in the 90s, they might not have even 2 layers. They might just have 1 layer of building paper or none. I don't know. I was still in school then, not graduate school, but so it depends on when they were built. But what we're seeing is that 2 layers of building paper in climates that are rainy is just not enough drainage. And then of course it's exacerbated by other design decisions like the sort of, so townhomes which are like 4 stories, just get more exposure, number 1. And then number 2, anything that doesn't have overhangs, these walls get wetter. A modest overhang on a 1 or 2 story house can reduce water deposition on that wall by like 50%, which is crazy. So if you go to this real clean line, modern look, your wall's getting a lot wetter than it used to. So it's just getting wetter, and it doesn't have the capacity to drain and dry. And that's the issue. So we could safely design stucco buildings without overhangs in 4-story, modern aesthetic constructed buildings if we included a drainage mat behind the stucco. So the stucco works. It's not a workmanship thing. It's a drainage thing. It's a design issue. What sucks though is that what sucks for people, real people, is that real people lose all of the equity in their house, which is their primary investment. And, some of this is done by people who don't care and are unethical. But a lot of it is by contractors who are following the code and thought they were doing a good job. So it's answering the question of who's responsible for this is really messy and difficult. And it also has to do with when this was done. Like, I would say that now there's enough information that we really should know this. That if you're, like the story I told of the multi-story, the tower going up, they should have known better. Like, that happened in 2019. That I consider that to be not meeting the industry standard of care. But for stuff that was built in the 90s, I guess we sort of knew about it then. It's hard for me to put myself in a professional's position back then. But I'm willing to acknowledge that it's pretty messy in terms of assigning responsibility for this kind of stuff. But now we certainly have enough information to know that this is a drainage issue. And if we provide additional drainage, we can use all the stucco we want.
Thank you.
The last stucco question, and I think we're right at our end. Brett Martin wanted to ask about the application of stucco using something like an Octoweld type bonder versus a traditional, wire connection, wire mesh, and what that means, what that changes as it relates to, to the drainage going on.
Okay, so I have to make sure I understand the question properly.
Yeah.
So,
I think it was going back to I think this was asked when we were talking about brick walls that have been covered by stucco, and I think so. The question, right? If you're on, do you want to just jump in and ask your question? I might be
that's correct.
bastardizing your intent.
No, no, you're actually directly on point. So, Christine, you were talking about the stucco over brick mass wall.
Mhm.
And so, historically in the Philadelphia area, back when I was on the street doing inspections, especially in South Philly, there was just this, industry practice of using a bonder instead of, wire mesh. And be interesting. I want to take a ride one day and see some of the projects that were done in the mid 90s. To see how they fared. But do you have an opinion on that type of application of stucco?
So when you're dealing with, the water management part on masonry with a masonry backup wall, masonry substrate is related to how much the stucco cracks. So which is also tends to be an aesthetic issue, right? So the wire meshes tend to be better, at controlling cracking in the stucco. So when I see people do this in high-end homes in Florida, where stucco is super, super common, what they'll do is they've got CMU is the masonry part, and then they've got like concrete slab edges, right? And they'll put a bonding agent on the CMU, but they'll put a mesh on the concrete, like the slab edge. So they'll use this sort of hybrid approach. And the reason they do that is because the bonding agent, its effectiveness depends on the substrate that you're putting the stucco on. So it's not, and I'm sure it's dependent on the kind of bonding agent you're using. And that's a level of chemistry that I can't intelligently speak about. But I'm sure that there's just as much nuance in that as there is in any of the stuff that I pay attention to. My preference is to use, if I can, like, while it works to direct apply this stuff all the time. We have a long history of doing that. It's all the European buildings that we love so much. They just direct apply it, the stucco onto the masonry, and it works out pretty well for them. But when I'm looking at something more modern and the desire is for that really clean, flat look, my preference is to specify not just a masonry substrate, but a masonry substrate with a stainless steel lath. And yeah, I don't practice to the level of getting the ins and outs, because it doesn't affect the water management, ends up being unaffected at this point. We're handling water in a different way. It ends up being mostly an aesthetic question. But the work that I tend to see that looks just really sharp is the combo approach, where they use they're not using the bonding agent, they're using or nothing. They're using the metal lath in addition. They do this kind of cool thing here in, I see this a lot in Texas, where what they'll do is they'll have a framed wall. So a typical 2x6 framed wall. And then what they'll do is they'll have a 2-inch space, and then they'll have a CMU veneer, but it's not 8-inch CMU, it's like 4-inch CMU. So they install it like brick with brick ties. And then they'll apply the stucco render over that, sometimes directly to the CMU and sometimes with the lath. I don't know why I'm having such a hard time saying lath today, but sometimes with a lath as well. And it looks sharp. And the geek in, I mean, it's not a very economical way to build, but the geek in me loves the use of the CMU veneer for aesthetic purposes, because it's a little bit like the difference between plaster and drywall, right? Lots of people don't care. Drywall is fine for them. They don't notice, they cannot tell the difference. But you spend some time in the industry, plaster looks different, right? In the same way, stucco applied on a masonry substrate, it looks different than stucco or eaves on a framed wall. And I like the look. What can I say? I appreciate it. I think it's cool. I like it. Is it a good use of resources? Not for me to say. But anyway, take that for what it's worth. What are you noticing in Philadelphia?
You're muted if you're talking, Brett.
I think most of the applications are in regards to stucco or brick veneer is a brick veneer, with brick ties over framed wall, or for stucco, you're seeing most stuccos applied to wire lath.
Yeah.
But I just thought about those projects in the past and how they would fare, not having control joints, where some of them did, but not having the weep screeds and the things where it's directly applied, where I would have conversations about, yes, stucco is a good water management medium, but it also wicks and stores water, as you noted. And so how does it dry when there's no space between the masonry brick mass wall and the stucco with not having a lath?
Exactly. Yeah, it's not exactly. Yeah, I didn't mention this, but you brought up control joints. So that's why they do this, by the way, in Texas, is they do the CMU veneer and then the stucco over the veneer. The reason they do this is because they don't want control joints. Now, the stucco still cracks. And this is what I tell any client who's actually doing this: your stucco will crack, but it's not going to crack as bad typically. And it's not going to be a moisture issue, because we've got this cavity where we're draining water. So the entire purpose of this is to further this aesthetic without control joints and the look of stucco on a masonry substrate, as opposed to a framed wall. So how much cost and expense do you want to invest in that particular look? You know, it's up to you. But it definitely, stucco cracks. It's cementitious. It cracks.
Well, I think that's a good place to come to the end. Thank you so much for all your time. I think, you know, there's a huge amount of appreciation in this room for the work and the research and the information, but also for the level to which it's made accessible so that more and more folks can understand what's going on and take part in the process and help troubleshoot and understand when there's an issue. So it's a big service you're doing, and we do appreciate it.
Well, thank you. I appreciate you guys. Thank you for the invitation. And it is always a pleasure to talk about this kind of stuff with fellow professionals. And I love this. You know, there's a lot of crappy stuff about social media, but the ability to connect with professionals doing excellent work in other places is, I think, a huge benefit to our industry. Every time I give a talk like this, it's not a one-way street. I learn stuff from you. I learn from what you guys are doing, the types of questions you ask. And it's stuff like this that helps enhance, I think, everybody's nuance in their day-to-day practice, which is awesome. So thank you for having me. I really appreciate it. And see you next time.
Yeah, so at Building Science Fight Club on Instagram, this YouTube clip will go up over the weekend. So if you want to share this will be on our page. And while you're at our events page, sign up for those next 3 events. We'll be back talking streeteries on Thursday. So everyone enjoy your Thursday, and thank you for coming.
Thanks, everyone. Have a good one.